Alright, it is time for us to begin our adventure in the world of looping by first taking a look at the do loop. That's right, the do loop. Sometimes referred to as the do while loop. Why, you might be asking yourself? Simple, because to do a do loop, there's a while involved. Let's go ahead and start out by looking at the basic syntax. The basic syntax is do, opening curly brace, which this is only required if there's multiple statements to be executed, but like we've been doing with if statements and everything else that's been using curly braces, we are putting them in even if we only have one line of code to execute, just to keep things nice and neatly formatted for you to read. So, do, and inside here, do the code that's to be looped. Now we're going to close our curly braces. And here's the kicker. While opening parentheses and some sort of test inside. Closing parentheses, and then do not forget your terminator, because if you do, this will be an error.
And while you're at it, throw a D on looped.
Do. L-O-O-P.
Code to be looped.
Aha, D. There we go. I knew that. I was testing everyone, but you just happened to catch it first. Okay, so the code to be looped is inside. Right now, we are simply showing one line of code in here, but because we are using the open and closing curly brace, we know that we can have multiple lines of code inside here. So keep that in mind. These are optional, just like with the if statement, if you only have one line. But you still must have the terminator, and your one line of code would still need to end with a terminator as well. I'm just throwing that out there in case you decide to be fancy like some programmers I've seen out there and put it all on one line. So it's do, and then console.writeLine, blah, 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 while the. All that on one line. Your code still has to have the terminator in it, the code that's to be looped. All right? Now, how does this little bitty structure work? It's real simple. Basically, we are going to, when we fall into the loop, we will execute what is inside here. Then we come down here to the while loop, and we take a look at this test. If this evaluates to true, that means continue looping. So while our test is true, we'll simply come back around and execute again. Then we check our test again. If the test evaluates to true, we continue to go back around and execute the code again. We continue this until the test becomes false. The moment the test becomes false, we exit out of the loop and code execution continues in your application. We're done with the loop. All right? Now, by looking at this with this little example I just gave, hopefully you can see where things can go wrong quickly if you don't pay attention to how you're handling your logic, meaning you could get yourself caught up in a situation where the test never becomes false. What you've just done is created an infinite loop. You have to be careful not to run into those kinds of situations. Okay, now that we've drawn the basic syntax for the do loop up here and we've butchered it to death with black and white markings, let's go ahead and draw out a real example and trace through it. So let me start out with an integer. So a variable named I, and inside I we shall initialize it with the value 1. Now let's loop. So do curly brace, and I'm going to indent here. Actually, let's go ahead and finish setting up our structure. So we'll go ahead and close this off, and while, now for our expression, while I is less than 5. And do not forget the terminator, because it will be a problem if you do. There we go. We have set up our very basic loop structure. We're going to continue looping as long as the value inside of I remains less than 5. Now, at the moment, if we just run this, we have just created an infinite loop. And inside the loop, we're not doing anything, are we, Logan?
No, nothing's going to affect I. And I right now is less than 5. Nothing ever changes that. So we'll end up with an infinite loop.
That's right. So let's put some stuff inside. What if we were to do a console.writeLine? Remember, from now on, I'm just going to do this because it's easier. So we're going to say write out something along the lines of I is or equals, so I equals, and then we'll just add I to it. So right now, if we were to run this, what are we going to see? I equals 1 over and over and over and over and over and over forever, okay? Until we break out of the program ourselves manually. Now on the next line, let's do I plus plus terminator. Now we all recall the plus plus operator is going to simply increment the value within I by 1. Now, what's going to happen when execution begins? Well, let me go ahead and first set up our variable. So here is our variable over on the stack. It is I, okay? Right here is our console. First time we go through, we initialize our local variable to a value of 1. Okay? Then we come into the loop. We execute the loop, the contents of the loop, once, no matter what the expression evaluates to. So it doesn't matter if we put, I equals 10, we're still going to fall through the loop and do what's within it at least once. And that becomes very important when we start taking a look at the differences between a do-while loop and just a while loop. So coming through here, the first thing we do is we hit this console.writeLine and we write out to the console I equals, and what is currently in I, because that's what we're telling it to do, the value 1. So I equals 1. Now, of course, since that is a console.writeLine, our focus is now down here because at the write line at the end, it's like you've hit the enter key. All right, so now we've just dropped down to this line, I plus plus. What does that do? It takes the value of I, which is a 1, and increments it by 1. So we now have a 2 being stored in the local variable I. Now we fall down to the while statement, and we ask ourselves in the expression, is 2 less than 5? The answer is true. It is indeed less than 5. So while true, we're going to continue the loop. That means we come all the way back around. I'm taking the long way. And then we jump back in here and we start right here at the very first line inside of the loop. So, which is write out what is in I. So now, I equals, and what is in I at the moment? The value 2. And since there's a console.writeLine, it basically had a new line appended to the end. So we fall down to our next line, I plus plus, which means we're going to take the contents of I and increment it by 1. And we all know that 2 plus 1 gives us the amazing value of 3. Once again, we come down to the while. And now we're going to take a look, is 3 less than 5? The answer is true. So once again, we start at the top of our loop code, which is write out the contents of I. So I equals 3. We fall down to the next line, so we're now down here. I plus plus, so we take what is currently in I, which is a 3. We increment it by a value of 1. It now becomes a 4. Once again, we go down to the next line, which is while. And let me go ahead and bring this down a little bit, just give me a bit more room. So while 4, is 4 less than 5? The answer, true. Because it is indeed less than. So once again, we loop back up here to the first line within the loop, and we write out I equals, once again. So I equals, what's the current contents of it? The current contents are 4. Okay, very good. So then we come down to the next line right here, and we're going to take I and we're going to increment it by 1. So 4 now becomes a 5 because everyone knows 4 plus 1 is indeed 5. We then come back over here to the while and we're asking, is 5 less than 5? Answer, false. They are equal. Since it is false, we do not loop back up. We continue with execution. So Logan, when we code this in a second, I'm going to go ahead and have you write out finished after the loop so that, let's go ahead and come over here and adjust this. Okay. Such that the last thing to get wrote out is finished. So this is what we should see on the console. I equals 1, I equals 2, I equals 3, I equals 4, finished. Now we have walked through the loop over here. We have traced it out. We see how it works from the moment we entered into it to looping back through, all the way to the point of where we exited out of the loop. Anything you want to add to this before you code it out?
No, I think that's got it.
All right, well, let's go ahead and jump over into Visual Studio real quick, and we'll set this guy up.
Okay.
A quick new console app.
So here is our new console app.
Okay.
And let's write out this do while loop. We're going to begin with that integer, so we can tell where we're at in the loop, int I, and we'll initialize it to 1.
Okay.
Now we'll begin the do loop itself. So we'll have do. We'll jump down and block this do loop in, so I can end it off with a while I is less than 5, and make sure we add our terminator.
Okay.
Now let's jump into the loop, and we need to do two things. The first is we need to write out the value of I. So we'll use the console to do a write line where we say
I equals,
and then concatenate on I.
Okay.
Now we need to increment I, so we'll simply say I plus plus.
All right, and that, now let's go ahead and put a finished.
All right, so let's do a console write line that says
Finished.
Finished.
All
and
right.
then I'll do a console read line just so we can see what the result
so
was.
it'll hold it up.
And there we go.
All right, so let's go ahead and build real quick. All right, looks good. So let's execute. All right, I equals 1, I equals 2, I equals 3, I equals 4, finished. Let's go ahead and jump back over here to the whiteboard real quick. I equals 1, 2, 3, 4, finished. It's exactly the same. So hopefully with our little example over here, you see how it works. Let's go ahead, Logan, and jump back over and just give them a demonstration of what happens if there is, and what instead of I++ you had I minus minus. Now let's go to.
Oh, yeah,
we got to close the app real quick. There we go. So I minus minus. So now what's going to happen? Each iteration through the loop, I is going to decrement, right? Mm-hmm. So if we run it now, let's go ahead now.
There should be something
actually, there is something interesting. First of all, is I less than 5? Yes, and it's going to stay less than 5, stay less than 5, stay less than 5, and then what are we going to add?
Well, then we get kind of a, I guess, would this be an underflow or an overflow?
It'll be an underflow, and we're going to wrap back around that. Let's go ahead and run it real quick. So here we go.
Though we probably...
Let's change it to like a byte or something.
So we can see it. Yeah,
just so we can physically, because it's going to go on and on and on, and an integer holds a really huge number. Actually, believe it or not, I don't know if you caught this, but in the couple videos back, when we were doing the remote control stuff and the knowledge thing, this actually hit me afterwards. You were typing in an int because we needed to bring that data in, and I said, yeah, so we can bring in 65,000. I don't know why I said that.
No, you're thinking 60. So
I'm thinking of a 16-bit. I sure am. So anyways, yeah, the good old days.
This will take a while because of the time taken to write out the line to the console. This would actually loop back over faster if we weren't doing the right line. But I agree with using a byte. That way we can see the output. We can see it underflow faster. So let's simply change I to a byte and see what this gives us. Oh, wait, hang on. Let me do an unsigned byte because we're going to go.
That's better.
So S byte. I mean signed byte, not unsigned.
No, I'm with you. And there you go. So basically you went all the way down to 100 a negative 128. And then what happened, Logan?
Well, then we wrap back around to a positive 127.
That's right, which happens to be... Go ahead.
I wonder if I could swap these lines so we see the line afterwards.
Sure, yeah, that's perfect. Because then they can actually see it. So all the way down to negative 128, and then there is the 127. And 127 at this point is no longer less than 5, so that's false, so we're going to jump out of the loop. And so this basically was an underflow. We just kept going lower, 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 lower until we hit the bottom bounds or the lower end of the range that can be held within that particular variable data type.
Right, so while at first it looked like an infinite loop, it was in fact not necessarily an infinite loop. Without any type of overflow checking, we would have never caught this.
You got it.
Or unless we let it run long enough.
So just a real quick example. That's all. Now, let's just for the heck of it, we're just going to use a little extra time here. Go ahead and close this, Logan. All of this could have been put on one line if you wanted to. Let's demonstrate that. Well, first of all, I could demonstrate it, but I'm going to introduce two things at once because we're going to throw a little logic in here. Take out the minus minus. We're going to go back to a plus plus situation. But watch this. Instead of putting I plus plus there, do it on the console.WriteLine. So you get I append to it, I, but let's do plus plus.
Okay, so
now we can take out that I plus plus all by itself. Now remember, all the way back in Volume 1 when we talked about expressions, there's a difference between plus plus first and plus plus after the variable name. With plus plus after, that means use the contents of I with our current line. And once we're done with it, the last thing that's going to take place because of operator precedence is going to be this plus plus. So if we come in here, I is 1, we're going to console write line I equals 1. After that happens, then we're going to increment the value of I to 2, and then to 3, and then to 4. So this right here allows us to simplify things just a little bit. Go ahead and run it just to show them this is working. Okay, 1, 2, 3, 4, and finish, just like we had a few minutes ago. So that's cool. Go ahead now, Logan, and instead of putting it all on one line first, let's just pull out our 2 opening and closing curly braces. Again, I'm just demonstrating that and neatening it up just a tad by taking that space out between, there we go. So I'm just demonstrating that if you have only one line that's going to be within the loop itself, you don't need to have the opening and closing curly brace. Let's go ahead and run it. There you go. 1 through 4 then finished. And now put it all on one line just to demonstrate what we talked about at the very beginning. Though I do not recommend doing this, though I do see it from time to time. Big thing is here, when people write this out, it's real easy if you're a beginner and you're trying to be slick and put it all on one line for whatever reason. They leave this out because it reads. Go ahead and hit delete real quick. It just reads so well. Do this while that. But notice the little problem right here. It's expecting a terminator. So go ahead and put the terminator back in, and then let's run it to demonstrate that it functions just fine. 1, 2, 3, 4, finished. All right. So ladies and gentlemen, that is the do while loop. Very simple syntax. Do, the key word. Opening curly brace if you have multiple lines or just want to keep your one line looking nice and neat. Code inside of our curly braces that need to be loop. Closing curly braces. And then the big thing is while and then the test. So as long as the test is true, we will continue executing the code that is inside the loop. The final thing I want to reiterate, I said this a minute ago, is with the do loop, we will always execute the contents of the loop, always execute this at least once. So if we were to come in with a value of, let's say, 10, we're still going to execute the contents of the loop once. So Logan, let's go and jump back over and show that to him real quick. So we've demonstrated pretty much everything. So set that to a 10, and yeah, you can go ahead and put all that back together real quick.
Let's restructure this back out to mimic what was on the whiteboard.
Make a lot more sense.
So let me drop this down, drop this to its own line, drop this down, close the brace, and there we go.
And yeah, and you notice how Logan put the while below it. You can do it either way. Okay. So
I didn't even notice that.
Yeah, but that's cool. So it still works just the same. So now go ahead and run it. And look at this. I equals 10. Finish. So I equals 10. Keep that in mind. Why? Because we came down here, we ran the contents of the loop our first time, where we wrote out to the console I equals 10, and then after that, what did we do? We incremented it to an 11. Is 11 less than 5? No. Does that mean we continue the loop? No, we don't. We continue outside the loop, and that's why you saw I equals 10 finished. Okay? So with that, I think that covers everything that I wanted to talk about in regards to the do loop. It's very easy to use, and this will be one of the type of loops that we're going to be using in our games. If you have a loop that the contents must be executed for sure at least once, you're going to want to use a do loop, because the while loop and the for loop, that's a whole different story. And we're going to take a look at the while loop in the next video. So that is going to wrap up this video. Thanks a lot.